Hello, in this video I'm going to solve the following challenging problem on the topic of logarithmic equations. If a and b are positive numbers such that logarithm of this expression to this base plus logarithm of this expression to this base equals 2, then a plus 2b is equal to. Pause the video at this point and give it a try to see which one of the following options is the correct answer. This problem is chosen from Vietnam National High School Graduation Exam 2018. Okay, so let us solve the problem now. So this relation is given to you and you're supposed to answer this question mark a plus 2b. Of course, in order to answer the question mark, in principle, I need to know a and I need to know b. So I need to be able to find the values for a and b. This is, of course, one way of thinking about the problem. So you have two unknowns, but you have only one piece of information apparently here because you have one equality. So you shouldn't expect that. So let me bring the microphone a little bit closer. So you shouldn't expect that you should be able to solve this problem and find both a and b because you have one piece of information. Another idea might be that, okay, I start manipulating this algebraically so that a plus 2b appears in this expression, and hopefully I can find a way to answer the question mark with just one piece of information, because I am not going to find a and b individually. I am going to find a plus 2b collectively from this relation. But if you think in that way, and if you look at the expressions involved in these logarithms, there is no apparent relation between the expressions appearing here and the expression which is wanted. Okay? So this is why it's not a good idea to start manipulating this equation using all formulas that you know from logarithms. Okay, so probably it's a little bit deeper problem, so you have to tackle the problem in an indirect way. And usually this is the case if you want to find two pieces of unknowns from one piece of information. Might be understanding about inequalities will be very helpful. So let me try to give you an example. So if I ask you what is the sine, so let us give you a relation. Sine x squared plus sine y squared is equal to 2. You don't know x, you don't know y, and you have apparently one piece of information because you have one equality. But is there any way that I can find both x and y from this one relation? In this problem, the answer is yes, because I know something else from my previous knowledge in mathematics. I know that this one is maximally 1, and this one is also maximally 1. And on the other hand, I know that the sum of these two is supposed to be 2. So there is only one possibility that both of them has to be 1. So by looking at this relation, you can immediately realize that sine x squared is equal to 1, and sine y squared is also equal to 1. Yes? So this is one of those cases that I have two pieces of information, two pieces of unknowns, and one piece of information. In principle, I can find both of them. So thinking about inequalities in these kind of problems is actually very helpful. So, but this one is of course a much harder problem than that one. Okay, so let us see what we can do. Okay, so my claim, let me call this one L, is the left hand side L. My claim is L is always greater than or equal to 2, and I want to find the necessary and sufficient condition for L to be exactly equal to 2. So let me first convince you that in general, if a and b are positive numbers, L is definitely greater than or equal to 2. So how should I do that? This part shouldn't be very hard. So because you see, I start from here, and then I subtract 8ab And then, of course, to compensate for this subtraction, I add 8ab, and then, of course, I find. So what I have done is correct, because this one and that one are canceled, and I am left with this expression, so I'm allowed to put equality sign. But what is the benefit of doing that? Because the first three terms becomes 4a minus b to the power of 2. The first one squared, 2 times the first one times the second one, and the second one squared, and I copy and paste these parts, yes? So let me put them in a pair of brackets for the time being. And now you see what happens. This expression is always non-negative because this is one number to the power of 2, and 2 is even. So this means that this is greater than or equal to 8ab plus 1. This is already an indication that might be we are on the right track, because 8ab plus 1, which is the base of the second logarithm, somehow appears in this analysis. Okay. But one thing that is important, if I ask you when this equality holds if and only if this equality holds, and this equality holds if and only if this expression is 0, it means that b is equal to 4a. So let me write equality holds if and only if, IFF in math books or math literature, it means if and only if b is 4a. Okay, so let us have. Okay, now what do I have? I was able to prove that 16a squared plus b squared plus 1 is greater than or equal to 8ab plus 1. Okay, and I know that 4a plus 5b plus 1 is a number greater than 1. Why? Because a and b are positive. So when I calculate this, this becomes a number greater than 1. And if I have a logarithm whose base is greater than 1, the logarithm is an increasing function. What does it mean? It means that if this number is greater than this number, I can immediately conclude that the logarithm of this number to this base, yes, is also greater than or equal to the logarithm of this number to the same base. Yes? Yeah. So now let us go to L. So L is equal to this expression plus that expression. Yes? But the first part is greater than this one. Okay, so the whole L will be greater than or equal to this expression plus this expression. Yes, 8ab plus 1 to the base 4a plus 5b plus 1 plus logarithm of that expression 4a plus 5b plus 1 to the base 8ab plus 1. So far I was able to show that L is greater than or equal to this expression. If I ask you when L becomes exactly equal to this expression, equality holds if and only if this equality holds, if and only if this equality holds, if and only if this equality holds, and etc. So this means equality holds if b is equal to 4a, because that is crucial. Okay. But my claim is this number is definitely greater than or equal to 2. How can I prove that? Okay, first of all, I need a formula from the logarithms. I know that if I have a logarithm of a to the base b, I can write it as 1 over logarithm. I can interchange them. Okay, so in other words, these two numbers are reciprocal to one another. And that is exactly the combination that you see here, because this is a logarithm, this is the argument, this is the base, but this is the logarithm with the roles interchanged. Okay, so these two numbers are reciprocal of one another. And one more thing is that both of them are positive. Why is that? Because a and b are positive, so the argument is positive. Yes? And of course the base is also positive. Sorry, the argument is greater than 1. Sorry. argument is greater than 1, so this means the logarithm is positive. Argument is greater than 1, so the logarithm is positive. And then we also have a famous inequality. We know that if a is a positive number, a plus its reciprocal is always greater than or equal to 2. It is extremely easy to prove. And then a plus 1 over a becomes equal to 2 if and only if a is equal to 1. This is very easy to see. Let us double check. For example, I know that a minus a to power 2 is definitely greater than or equal to 0, because that's an even power. So if I raise it to power 2, it becomes a squared minus 2a plus 1 is greater than or equal to 0. I move 2a to the other side, so it becomes a squared plus 1 is greater than or equal to 2a. And now, because I have assumed that a is positive, I can safely divide everything by a without being worried about if I have to interchange the sign or not. So I divide everything by a, so this becomes a, and this becomes 1 over a, and this becomes greater than or equal to 2. So inequality is proved now. And then if I ask you when this equality holds if and only if this holds, if and only if this equality holds, if and only if this equality holds. It means that if and only if a is 1. Okay, so now what I was able to show for you is correct, because this number is reciprocal to this number according to this formula in logarithms. And because the arguments are greater than 1, logarithms are positive, so this condition is also satisfied. So this expression should be greater than or equal to 2. So I was able to prove my claim that this L is greater than or equal to 2 always, regardless of what values of a and b, of course, if a and b are positive. But now the problem wants L to be exactly 2. Okay, so I want to have this equality. So equality here holds if and only if the equality everywhere holds. Yes? For this one to be equal to 2, we just learned that number which is added to its reciprocal should be 1. So L becomes 2. So let me write it here for you. L becomes 2 if and only if, so let me bring my stick, if and only if this equality holds, which means that your number involved with its reciprocal should be 1. So this means that if and only if logarithm of 8ab plus 1 to the base 4a plus 5b plus 1 should be 1, and that equality holds, which we'll learn happens if and only if b is equal to 4a. Okay, so now I have 2 pieces of information instead of 1, and I have 2 pieces of unknown. So I can solve this problem in principle and find an AB, and when I found the NB, I put it there, I find my question mark. Yes? So what does it mean? This means that these 2 numbers should be the same, because logarithm of this number to this base is 1. So this means that 4a plus 5b plus 1 should be 8ab plus 1. 1's are cancelled. So this means that I have 4a plus 5b is equal to 8ab. I also have this piece of information. So instead of 4a, I put b. Yes, I put b. Plus, I have 5b, and this one can be written as 2 times 4a times b, but instead of 4a, I put b. So this becomes 2b squared. So this means that I have 2b squared minus 6b equals to 0, because this becomes 6b, I move there. I factor a 2b out, so it becomes b minus 3 equals to 0. Either b is 0, but this is not acceptable because it is mentioned that a and b are positive, so b is not 0. So this means that the only possibility is that b is equal to 3. And if b is equal to 3, a is 3 over 4. So yes, a becomes 3 over 4. But now I want to answer the question mark. The question mark is a plus 2b. A is 3 over 4 plus 2 times b, which is 6. And if you calculate this, it becomes 27 over 4. Yes? So if we go back, yes, so the option D is the correct option that we have to choose for this problem. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.